Hi guys, so today we will be discussing modes of enzyme action. Okay, so there are two proposed theories for enzyme action and they're pretty easy to understand. So let's look at them. First one is known as the lock and key hypothesis. A very easy way to understand it is to understand the lock and key mechanism that we use on a regular basis. The key to my house will not work on your door, your keys will not work on my door. That means that every key has a specific lock, right? Similarly, or every lock has a specific key to be more precise. Similarly, here, if you consider the enzymes to be locks and their active sites are made such that only specific keys or substrate could come and sit on them. So, your enzymes are your locks and your substrates are your keys. So, when the specific substrate, so let's say there was also a substrate which looked like this. Very bad at drawing stars. So let's say a substrate that look like this. Okay. There are 3 substrates available, 3 keys available, but out of them only these 2 will be able to fit. Only also in the specific locations. Once they would come and attach to the active sites, you would have the enzyme substrate complex. And once when the enzyme substrate complex has done its reaction, the reactions have happened inside it, you will have the products and the enzyme will become free again to go ahead and fit into another lock, right? Another key. So it's a very easy thing to understand. The other system, the other hypothesis that was proposed is known as induced fit theory. Now, induced fit theory is a slight modification of the lock and key theory. Here it says that there are, in the active site, there are 2 groups. One is the buttressing group and the other is the catalytic group. The buttressing group helps to support the substrate when it approaches the enzyme. The catalytic group, however, makes changes within the structure. So it breaks down bonds or makes changes within the structure of the enzyme to be able to induce a fit such that the substrate could sit on it or could work on the active site. Okay. So for example, this is the enzyme, this is the substrate, let's say, and this is the enzyme. When it will come, the buttressing group will hold it closer to the substrate, to the enzyme, so that the modifications can happen, and depending on the chemical nature of the substrate, the catalytic group is going to change the active site so that the enzyme substrate complex can be formed. Once the enzyme substrate complex is formed, the reaction will happen and the products will be given. Both of these are products, right? So here breakage has happened. It's a catabolic example. And the enzyme will obviously stick to the active site configuration of this particular substrate. Once a new substrate will come, you will have certain modifications done again so that it can give you a product, right? Even though this is true, it's also true that for example, a starch digesting enzyme will never be able to catalyze its active site to give you a protein digesting enzymes. But we still do have classes of enzymes, right? So starch digesting enzymes will be able to dissolve starches, cooked and uncooked both. So whatever chemical changes necessary, they will do it. Proteases will be digesting proteins. So whatever minimal amount of changes or modifications are necessary will be done to induce a fit such that you have the enzyme action. I hope this much was clear. We will finish off enzymes in the next video. Thank you.